In this video, we're going to take a look at how we would use a calculator with the trig functions, and we'll use it in a couple of different ways. The first thing we need to keep in mind is that, as we've discussed in previous videos, the measurement of the angle can typically come in two different ways, either degrees or radians. And so it's a good idea to double check and make sure that you've got your calculator set to the right setting. And double check to make sure which unit of measurement is being used for the degree measurement. In calculus, most of the time it's kept in radians, and so it's probably a good idea to just go ahead and set your calculator to radians, and then change it to degrees if you come across something that needs it. So we're going to go ahead and do that. The calculator, the way to change it to radians is to go ahead and press the mode button, and that'll bring up your menu settings. It's typically found in the third location or the third row. If you hit enter, it'll switch it from degree to radian. If you take a look at the top of your calculator, you can tell whether you're in degrees or radians. Off on the right side, just before the end, it says radian or degree, and that's one way to do this. Now, the calculator has the three standard trig functions above the number pad: sine, cosine, and tangent. And so, if we were going to use the calculator to find, for our first example here, these values, this is how we would do it. I press sine, it's going to give you that parenthesis already, so everything within there is what the calculator is going to look at. We'll go ahead and enter 2, and our solution, so 2 radians, the value for sine of 2 radians is 0.9092. So we'll go ahead and say this is equal to 0.9092. We don't necessarily have to go to the last function there, but we'll leave it at that. Tangent. In order to enter this again, we use the tangent button, and we're going to enter in negative pi over 5. Now the negative, keep in mind, is the negative that's underneath the 3. So negative, press our pi, which is above the caret, second pi, division, and 5, close parentheses. Be sure to close the parentheses. And be sure that all of that's in the parentheses. Without it, it will be just taking a little part of it. When you do that, that's going to give us our negative 0.7265, or if we round up for 3, it would be negative 0.727. Either one would be fine. Equals negative 0.727. Okay. Now, for the reciprocal functions, the secant, the cosecant, and the cotangent, remember the reciprocal means it's 1 over, and so we're going to take a look at the secant as 1 over cosine. So when we set it up in our calculator, it's going to be 1 divided by, and then we're going to go ahead and do our cosine. In this case, and we're doing the 1 over the cosine of 1.3, so 1.3, close our parenthesis, and that will give us our answer of 3.738 equals 3.738. So again, when you're doing this for secant, cosecant, or cotangent, use the 1 over button, or just type in 1 divided by, and that will give you the reciprocal of those functions. Now, for example 2, we're going to go ahead and use our calculator for this as well. This is a little more involved in that we need to go ahead and set up the relationship between that angle and the sides of the triangle. So in this case right here, for example 2a, we've been given a triangle with an angle of 0.5 radians. With an opposite side of 5, and we're trying to find the hypotenuse. Now, in the trig functions, the one that deals with opposite and hypotenuse is going to be sine. So we're going to go ahead and set up our equation in that manner. So sine of 0.5 and we'll put the r up there just so that we know that it's radians, is equal to the ratio of opposite over hypotenuse, which is 5 divided by x. Now, we're going to solve for x, which means we need to move the x out of the denominator. And we'll do that by multiplying both sides by x, which is going to give us x times sine of 0.5 radians equal to 5. Now we just got to get the sine from the side the x is on now and put it to the other side. So we're going to divide that out to both sides. And we can find our x by plugging that in. Okay, so our x is found. I'll just go and rewrite that just so it becomes a little clearer. X is equal to 5 divided by sine of 0.5 r, which when we plug it into our calculator, that's going to be 5 divided by, again, our sine value, 0.5, close our parenthesis. And so we now know that the value of our side, the hypotenuse there, is 10.49. Sorry, 10.429. Okay. With our, and in this case, there's no units for the length of the side, so we're not going to worry about it. For the final example here, 2b, we've been given two sides, and we're supposed to find theta, or find the value of it. Now, to do this, we're doing what's known as an inverse function. Okay, we're gonna work backwards in order to get our values. So we have an opposite and adjacent, and that can be found by either using the tangent or the cotangent. Okay, we're going to go and stick with the tangent. It works easier with the calculator. So we've got our tangent of theta is equal to opposite over adjacent, so 2 centimeters over 5 centimeters. And in order to find out what that angle is, we're going to go ahead and we're going to multiply both sides by our arctan, or inverse tangent function. And that's written like this, tangent minus 1. Okay, and you can find that on your calculator above the tangent function. So that eliminates our tangent. What we're left with is our theta, or angle, is equal to the tangent minus 1, or arctangent, of 2 over 5. Okay? And so to plug this into the calculator, the arctan is above the tangent, so second and tangent, that gives you the minus 1. That's how you know that you've got the inverse. Plug in your ratio, which is 2 divided by 5. Close your parenthesis, and that will give you an answer of 0.381, if we round up, radians. So 0.381 radians. That's going to be the angle that theta represents.